simplifying these fractions.
GCF.
Right, the problem.
We found GCF, and if we didn't have a GCF, what did we do? We factored, right? So, step number one. Okay. Step number one, factor all the polynomials. Okay, step number one, factor all the polynomials. Same step we did last night first. Okay, very similar processes. Except now instead of having 2 to factor, now we're going to have a possibility of how many to factor?
3.
Why 4, Jonathan?
Because top and bottom.
Okay, top and bottom of fraction 1, top and bottom of fraction 2, right? Because we're multiplying 2 fractions together. So possibility of 4 factors that we need to do, okay? That's why I said the better off we were at factoring, the easier these sections will be. Okay, so we're going to factor all the polynomials. Step number 2. When we're simplifying these fractions for multiplying purposes, we're going to simplify vertically, up and down, just like we did last night for our homework when we were simplifying rational expressions. But remember, we can also simplify on the diagonal too. So top left and bottom right can simplify, and bottom left and top right can simplify. You can simplify on those diagonals as well. Once you've simplified everything, the last part's pretty easy. You're going to squish together the numerators that you have left on the top. Okay, so the top left and the top right, you're going to squish those numerators together so that it forms one single row. Technology issues. Alright, and then you're going to do the same for the denominators. So you're going to take whatever's left on the bottom left and whatever's left on the bottom right, you're going to squish those together to form one single denominator. Okay, because when you finish these problems, you should have one single fraction, right? You should have multiplied together the left fraction and the right fraction and squished it together to make one fraction. Okay? So that's where we're at. Factor all the polynomials, simplify vertically and diagonally, squish together what's left on the tops, and squish together what's left on the bottoms, those numerators and denominators that you have left over. Okay? And that's going to be your answer. Yes, ma'am?
When you're simplifying vertically and diagonally and
Yep.
would you simplify diagonally or vertically first? Would it affect?
It does not matter. Okay? You can just start simplifying. As you see a binomial that matches another binomial, go ahead and cross them out. Okay? Other questions on that process? Alright, let's go ahead and look at dividing. Dividing is going to be the same as what?
Multiplying.
Dividing is going to be the same as multiplying, except we're going to add one step. Where are we going to add that step into the process?
Keep, change, flip.
Keep, change, flip is the step we're going to add. We're going to add it at the beginning. Good, guys. Okay, we're going to add keep, change, flip. Everything else is going to stay exactly the same. And it's so much so that I'm not even going to write down a second process step. Okay, we're going to keep, change, flip, and then we're going to follow the multiplying rules.
Wait, go first.
Okay, so we're going to keep, change, flip first. Okay, keep that first fraction the same. Change the division sign to a multiplication sign. And flip that second fraction over to the reciprocal. Alright, so keep the first fraction the same. Change division over to multiplication. Flip that second fraction over to the reciprocal. Johnny's.
Why couldn't you flip the first one? Why could you do that, or would it all be wrong?
Because when you're talking about, so this whole keep, change, flip, raise your hand if you know why we keep, change, flip. What property, this is going back, properties, which property of mathematics allows us to do this keep, change, flip process? Which property says that dividing is the same thing as multiplying by the reciprocal? It's not gonna be a hint.
You-
Is it in our notebook?
It's one of your islands.
Identity.
It's not identity.
Inverse.
Identity means to stay the same, right?
Inverse.
Inverse. Okay, so the multiplicative inverse says that dividing something is the same thing as multiplying by the reciprocal. When we're multiplying by the reciprocal, that means the second fraction is the reciprocal, right? So multiplicative inverse, multiplying by the reciprocal is the same thing as dividing. Just like adding the opposite is the same thing as subtracting. So I could say 4 minus 4 is 0, or I could say 4 plus negative 4 is 0. You always change that second piece.
Okay.
So that's where that stems from. Great question.